Hello, this is a short movie to introduce our first Institute of Coding demonstrator implementing the LinkChain architecture. Before you watch this movie, we recommend you watch our movie called Introduction to LinkChain. This will give you a comprehensive overview of the LinkChain architecture that this demonstrator implements. We have been creating a system where students can claim badges that go onto the blockchain as tokens and where the data for the badges is stored in their personal data store using Solid. Solid is a web platform created by Tim Berners-Lee, inventor of the World Wide Web, that allows users to create their own pods or personal data stores and control who can access the data held in them. For more details, please watch the Introduction to LinkChain movie mentioned earlier. For this demo, we have created 4 different views. The Student VLE view, where we are imagining that the student is at a learning institute and using a virtual learning environment. The Student's Solid view, which is an interface where they can interact with their personal data store. The Issuer view, where the institute can manage the badges they have given out and revoke them. And the Validator view, where people like potential employers can upload one of the badges a student has given them and validate it against the blockchain. I should explain, before we open the first view, that for this demo we have chosen to use the badge imagery from one of our Open University summer schools called Summer of Code. We have previously conducted a small-scale student-facing experiment putting the badges earned by students on the Summer of Code course onto our blockchain as smart contracts. We have used a small subset of that data, but anonymized, as the data for this demo. So let's start with the Student VLE view. Imagine our demo student, Student 1, has already logged into the learning environment and has gone to their badge list. Here you can see that they have been awarded 4 badges by the learning provider, or as we call them, the badge issuer. You can see from the grayed out buttons that 2 of the badges have been claimed by the student and 2 have not been claimed yet. The first thing the student has to do before they can claim a badge is to log into their personal data store, and that's what this button here is for. So we have set up a Solid Data Store service at the Open University, and that is what we're going to use now. I am now going to log into my Solid pod as Student 1, our demo student. And now I am logged in, you can see that the 2 claim buttons have become available. So let's look at the badge issuing process in a little more detail. After the student has logged into their Solid pod, the issuer creates the open badge file and adds any evidence files, hashes each file, and then writes the files to the student's Solid pod. It then creates a token metadata file, which includes the URLs to the badge files in Solid and the file hashes, and it writes the metadata file to IPFS. It then calls the token contract on the blockchain and creates a new token for the badge, passing in the IPFS URL to the token metadata. Lastly, it updates the open badge file in the student's Solid pod, adding the signature section of the JSON-LD, which includes the details of the blockchain token for later validation of the badge. So let's try claiming a badge and see what that looks like. Let's claim badge 8. The first thing I must do is pick where in my personal data store I want to put the files. Now I want to put my badge data in my private data store area, so I'm going to select the private folder, and then the badges folder. Once I have selected the folder, the VLE will create the token on the blockchain and write the files to my data store. Now that the student has claimed the badge, the claim button is grayed out. So let's now look at what the issuer might see in the issuer view. Here you can see a list of badges that this issuer has issued. By clicking the arrow against a badge, the issuer can see who they have awarded the badge to and if that person has claimed it yet. For example, here you can see Student 1 has now claimed their Summer of Code 8 badge. If the issuer wants to, they can revoke that badge, and that means the badge token will be burnt from the token contract. If I go back to the VLE view, you can see the badge has now been revoked. And if the issuer wants to, they can reactivate it and allow the student to claim the badge again. And now I can claim the badge again. So what does the student see if they go to their Solid Badges plugin? This is a demo interface for how students might manage their badges in their personal data store. At present, in this demo, we are requiring the student to enter their blockchain account number. So I will put in the account number for student 1, and that will load the badges they have so far had added to their store. So let's look at what the Solid Badges plugin has just done in a little more detail. First, the plugin goes to the token contract and requests all the token details for the given blockchain account. This includes the IPFS URLs pointing to the token metadata. Then the plugin goes to IPFS and gets all the token metadata files. It uses the token names and images from those files to draw the list of badges on the screen. It also takes the URL details of the open badge files and any evidence files and creates the download buttons on the badges list. If the student wants to download a badge or badge evidence files, they first have to log into their Solid pod through the plugin, and then the plugin can retrieve the requested files from Solid. So here you can see the 3 badges that the student earned and claimed, and you can imagine that they could have lots of other ones. Now, something that the student may want to do then is share the data of one of their badges with a potential employer. And to do that, they would need to download it from their pod and send it to their employer. In this case, there wasn't any supporting evidence, so it's just the open badge file that would be downloaded. As I am already logged into Solid in this browser from earlier on the VLE page, it hasn't asked me to log in again now. But if I hadn't been connected to Solid at the point I pressed the download button, it would have popped up the same login box with the purple buttons you saw earlier. I will now save this open badge file to my desktop so we can use it in a moment for validation. Let's now imagine I'm a validator who's been given a badge file by a prospective employee and I want to go and check it's a valid badge. The first thing I need to do is select the badge file to validate, which in this case is the one I just downloaded from Solid, badge 8. In the validator view, you get an immediate tick or cross to save its passed or failed validation. Let's now look at the validation in a little more detail. The validation process is made up of a series of items that need to be checked. If any item fails the check, the whole validation fails. The first step in the validation process is to extract the badge JSON LD metadata that's embedded in the badge file. In this box you can see all the JSON extracted and prettified to make it easier to read. We have also used color coding in this interface to make it easier to match up important items of information in the validation process. In the next box you can see the raw unprettified JSON with the last section of data, the signature section, taken out. It is this part of the JSON, without the signature section, that is hashed when the badge is created. We can calculate the hash now by pressing this button. The unique hash number for a badge JSON goes into the signature section of the badge metadata, and also into the IPFS token metadata, which we'll look at later. We can see here that the calculated hash matches the hash in the signature section labelled target hash. In the next box, we have displayed just the signature section of the badge metadata for ease of reference. In the next section, we look at the token for the badge. We have the source ID from the signature, which is the token contract address, and we take the token ID from the signature that represents the token of this badge. And we use those 2 pieces of data to fetch the information about the token representing this badge from the blockchain. So if we press this button now, we can fetch the data from the blockchain for token 5. We can now check that the token owner, also known as the recipient, that their account number matches the recipient profile public key in the badge JSON. This is the student's blockchain account, which you must imagine they have separately validated as theirs with the employer. Next, we can check that the badge's issuer blockchain account number matches the verification public key in the badge JSON. You have to imagine that the badge issuer advertises their blockchain account on their website for separate validation by the employer. Next, we can check the token metadata. Each token in a token contract is a unique token called a non-fungible token. We associate a unique IPFS URL with each token that points at additional metadata about the token. So let's press this button and fetch the token metadata from IPFS. By default, the token metadata has a name, a description, and an image. And it is this data that crypto wallets would use to draw the token. We have then extended that to add URLs that point at the badge file and any evidence files that have been written to the student's solid pod. In addition, we also add the hashes of each file put into solid. Because IPFS hashes each file added and uses the hash number in the file's URL, the token metadata is secured and means that the student cannot modify a file in their pod without detection. So with this entire system, we put the underlying data of the badge and any associated evidence files in the control of the student. They can decide who they share those files with, but using the blockchain, there is a clear validation path so that anybody can check that the badge the student is presenting to them or any associated evidence files have not been modified after they were issued. Since producing this first proof of concept, we have gone on to create an Institute of Coding badging platform. The IoC badging platform has been used by a number of universities, including Exeter, Sunderland, Queen Mary, and the Open University.